Hello, everyone. Welcome to the launch of this RICCAR webinar series being organized by the United Nations Economic and Social Commission for Western Asia. My name is Carol Shushani Sherfain. I'm the Chief of Water Resources in the Climate Change and Natural Resource Sustainability Cluster at ESCWA, and I'm also coordinator of RICCAR under the Arab Center for Climate Change Policies. This webinar training series aims to share with you some climate change assessment fundamentals and ways in which GIS can be used to access and analyze climate change data to conduct regional, basin, national, local level analysis based on the collaborative experience we've been having implementing RICCAR for the last decade. This is a 6-week webinar series that will be held each Wednesday from 3 to 4 p.m. Beirut time, start all the way through August 5th. Each module will be limited to 1 manageable hour, so for you to enjoy over the summer, or to view via recording following each session if you want to go and check back on any of the training tools presented. Today we launch the series. With Module 1. But before we start, we'd like to kindly share with you a few guidance points for our live participants. This webinar, the webinar page is shown above. You've already seen most of this before, for those of you who have already accessed the information. But the PowerPoint handouts are available now on the website in English and Arabic, and they will be there for each module. The link to the live event for this module and future modules will be posted on this website the morning of each session, and the recordings will also be made available following each session on that site. As we have over 100 registered participants, actually 443 as of an hour ago, we are broadcasting these webinars as live events. Unfortunately, this means that we're not able to interact with you using your audio or video tools. However, we encourage you now and throughout the event to please share with us your name, your affiliation, and your country of origin where you're working through the Q&A chat, so others know that you are connected and so that we know that you have joined. Please also don't hesitate to use the Q&A chat to offer comments or pose questions at any time during the session. Dr. Marlene Thomas-Skewis, who will be delivering the next 5 webinars in this series, is online to respond to your questions, as well as Joël Comer, who is coordinating RICCAR with us, and they will be responding to you to any questions live during the chat, and you could submit your questions, be it in English, Arabic, or French. At the end of this presentation, I'll respond to any lingering questions that may exist, while noting that we will respect the 1-hour mark to make this manageable for everyone. And then we are very happy to follow up with you by email following the sessions. So with that, let's get to it. So this first module on RICCAR regional climate modeling and hydrological modeling datasets, an introduction, will provide some fundamentals needed to better understand and pursue climate change analysis at the regional level, and specifically in the Arab region, but the tools are valid for other parts of the world. And we know that we have members and participants here attending from outside the Arab region, and we welcome you to this event. A few slides, however, have also been added at the end of this presentation to introduce you to how RICCAR regional climate modeling projections and hydro modeling outputs are being used to inform our integrated vulnerability assessment, which we delved into more deeply in the final 6th session of this webinar series. So we just wanted to provide you with a sneak peek to that. The presentation will close with a brief introduction to our regional knowledge hub tools and resources that can help you find out more about our publications, training tools, and help you to pursue your own climate analysis with the data sets. So let's provide you with some background on RICCAR, because its source really makes a difference on how we move forward. RICCAR began because in 2007, it was the first time that Arab countries collectively issued a statement about climate change. Selected countries had, of course, worked on climate change, Jordan, Tunisia, Morocco, but there had not been a collective understanding about climate change in a common statement until 2007. That declaration actually asked to improve understanding about climate change impacts on the water sector, given we are a water scarce Arab region, and then what it means for various sectors. That declaration then led into a series of ministerial declarations issued by the Arab Economic and Social Summit, by the ESCWA ministerial session, by the Arab Ministers of Water, the Arab Permanent Committee for Metrology, and also Ministers of Agriculture and sector intergovernmental processes to ask for more understanding about the impacts of climate change on water and water-dependent sectors. And that was indeed how RICCAR came to be. And the works for the last decade has been informing work on the environment, foreign affairs and planning, including negotiations on climate change, water, metrology, agriculture, etc. So specifically what we have been aiming for under RICCAR through this collective United Nations League of Arab States initiative is to assess the impact of climate change on freshwater resources in the Arab region through a consultative and integrated regional initiative that seeks to identify the socioeconomic and environmental vulnerabilities caused by climate change impacts on water based on regional specificities and regional concerns. In doing so, RICCAR is providing and has been providing a common platform for Arab states to assess, address, inform responses to climate change impacts on freshwater resources and foster dialogue, priority setting, and policy formulation at the national and regional levels. And this has been used already for assessment, adaptation, mitigation, and of course, negotiations policies. I would like to highlight that while ESCWA coordinates the RICCAR initiative, this regional initiative on the impact of climate change on water resources and socioeconomic vulnerability in the Arab region, it would not be possible without our partners, both in the United Nations system and at the League of Arab States, as well as our global partners and experts, and without So how are we pursuing this? Well, RICCAR is made out of a four-pillar structure of work that deals with a regional knowledge hub that we'll talk about at the end, where you can access information. A core component of the work is capacity building and institutional strengthening, and awareness raising and information dissemination. But the assessment work itself is really focused on linking climate change assessment to vulnerability assessment into an integrated framework. And we do this by linking impact assessments, which many of you are probably already familiar with. This is the impacts of climate change on the biophysical environment. And we do this through dynamically downscaled regional climate models, modeling that is nested in global models. And the outputs of that are put into hydrological models to have an impact assessment outcome. And then that is used to inform the vulnerability assessment. And this is done at the Arab regional level. So this is why it's called an integrated assessment, because it doesn't stop at impact assessment, but also links to vulnerability assessment. So how do we put this together? Well, the regional climate models have been generated for the Arab region at a scale of 50 kilometers square or 25 kilometers squares to date. Several projections are generated based on nesting the regional model in different global climate models or global circulation models. Several projections, at least three, are then combined into an ensemble so that we have a good understanding of the range of uncertainty associated with projections and the range of possibilities in the future. And then those projections, in turn, are informing various hydrological models to provide the comprehensive impact assessment. Because of the importance of extreme climate indices and extreme climate events, we use also the regional climate modeling outputs to extract extreme climate indices that can help us understand better not only the basic indicators, climate variables such as temperature and precipitation, but others. And we'll get into that a little bit more. So how does this work? Again, for the non-climate scientists out there, just some basics so we better understand where this comes from as we move into the GIS components later on in this webinar series. We have to think about regional climate modeling, or indeed even global climate modeling, in terms of a 3D grid of boxes, of cubes. And inside each cube, the different connections and interlinkages and interdependencies caused by the water models, by atmospheric pressures, by radiative fluxes and forcings, all this is computed within a within the cube, which decides the scale of the model. And then those are connected to get a better understanding of climate change across a given area. And inside each of those cubes, you're able to generate a host of essential climate variables. The ones that are most common, of course, are precipitation and temperature. As you can see, these are outcomes of the atmospheric component of essential climate variables, and they are generated per grid box. So again, depending on the scale of the grid box is the level of interaction that is generated for the outcome. For RICCAR, we have temperature and precipitation coming out of the raw outputs from the regional climate models, but also we have bias corrected outputs available for the RICCAR projections, and those are openly available to inform your analysis or use for your own modeling work. We also you also have the ability to access through RICCAR other essential climate variables, which we discuss much more during Module 5 later on in this webinar series. But for example, you can access information, the projections for wind speed and direction and humidity, which can be used for projecting sand and dust storms, which is something very important for our southern tier in the region and the Arabian Gulf. A snow cover is also available, and that can be very important for, again, for Morocco and Lebanon as we look at water and recharge. That noted, these essential climate variables that we generate in the model will focus on the atmospheric and land-based essential climate models. We are working on RICCAR with the RICCAR regional climate models as a land-based model. Accordingly, we do not have oceanic variables. We are not doing ocean circulation models. And in that regard, we are not engaged in sea level rise analysis, which also requires other information associated with topography on the coast, etc. So really it's the atmospheric and land essential climate variables that can be drawn from our work and from regional climate models that are land-based. So we were talking about those cubes. What's important is the size of those cubes that are creating the outcomes. And the scale over this has really been dramatically improving over time. As I'm sure you might know that the IPCC in their first assessment report way back in 1990 was able to generate global climate modeling outputs at a scale of about 500 kilometers square. So you can see how this is rather blurry in terms of the region. You're not even quite sure what region it is. As computing powers and the models improve, we can see that the scale has improved dramatically. We can see that the second report, it got a scale of 250. By the beginning of this century, in the third assessment report, we got to a scale of about 180 kilometers square. 2007, it got down to 100 kilometers square. And additional resolutions are definitely coming along at the global scale and finer resolutions. But this, in the end, is global modeling. And what we have been able to produce under RICCAR as the science has developed is created regional climate outputs and assessment outputs at a 50 by 50 kilometer scale and even a 25 by 25 kilometer scale for the entire Arab domain. Why is this important? Well, as I mentioned before, RICCAR is coming from out of an intergovernmental process. The countries needed to find a way that they can talk and address climate change collectively. And what was coming out of the Intergovernmental Panel of Climate Change and the discussions about regional domains and the averages in terms of climate change impacts in these domains, we can see that our region here was segmented quite significantly across various averages. So it's hard for a Morocco and an Oman or an Iraq and a Sudan to talk collectively to assess climate change impacts on the Arab region and what should be the priorities. These regional domains improved a bit. As you can see, it went in 2013 to be a bit broader in terms of the space provided for the domain area, but still the entire Arab domain was not covered. And then these are the spatial boundaries for the 5th assessment report, and it's actually being used right now for the 6th assessment report, and the Arab region is still not there. So there was really an interest as we launched RICCAR and we're servicing the Arab states to find a way to have a regional domain that worked for the Arab states. At the same time as RICCAR was set up in 2010, work was being launched by Philippa Girgio, Colin Jones over at SMHI, Hassan Assar, as to what we could do to coordinate regional climate downscaling experiments. And in 2009, they set up a preliminary set of domains where different climate centers could collaborate on generating projections for certain areas. As RICCAR was launched in 2010, this provided a great platform for us to also create a domain that was important for our geopolitical region. The Swedish Meteorological and Hydrological Institute therefore started convening and consulting with different climate modeling centers through RICCAR and with our RICCAR partners to see how we might frame this for the Arab region. A lot of research centers became quite interested in this opportunity. And we found that several institutions were able to contribute to the framing of the domain and then later on to generating projections even for this domain. And what resulted is that CORDEX, this coordinated regional climate downscaling experiment that was first conceptualized in 2009, was able to approve a MENA, a Middle East North Africa domain, which we call in RICCAR the Arab domain, that covers the region that we conduct our work in for regional climate modeling. So why is this interesting? Well, first, it covers not only a biophysical region, but a geopolitical region, because there are differences in forcings related to the different parts of this area. But we have therefore framed an area that allows us to generate regional climate models that allows us to consider not only the national boundaries of the Arab states, but also those that are associated with the water sources, and most important, the transboundary water sources that affect water supply and availability in downstream countries. So that is why the Arab domain is much larger and is also quite interesting for other parts, for other regions, because we extend to the headwaters of the Nile, we extend to the headwaters of the Tigris and Euphrates. The consideration of the changing weather patterns and warming of the Indian Ocean and how that affects extreme weather events in the southern Gulf area, Arabian Peninsula, is included. So this larger domain is the way in which regional climate modeling outputs were generated to inform Arab states, but again, can be helped to inform the Mediterranean countries, Turkey, West Africa. And we already know that they have been used by researchers in those areas to advance their work on climate change as well. Just as a highlight, while we are focused here on the Arab domain, I wanted to mention that we have initiated work with SMHI, with the support of the Swedish government and the League of Arab States, to have new modeling projections that will come online at the beginning of next year for the Mashriq domain. You can see the area here. We'll have 6 projections coming out that will be bias corrected and available for the business as usual scenario. And these outputs will be generated at a 10-kilometer scale. That's how much the climate science advances just 1 year after the other. And these will be available again later on. But for the purpose of this presentation, we'll focus on the Arab region. Now, once you understand the scale and the area that you want to look at to pursue your climate change analysis, you have to figure out what scenarios you want to use, because in the end, we're looking at the future. We need a set of conditions to frame how we are going to look at climate change in the future. Now, way back in the 4th assessment report, a lot of people were working on SRESs, this special report on emission scenarios that were more socio-economically oriented, getting to average temperature increases on different parameters. But in the last assessment report, AR5, which was issued started issuing in 2014, they started to use representative concentration pathways, RCPs. And this does not really focus on the source of the emissions, but rather what are the forcings in the atmosphere that would exist, and then how do you model within the context of that condition. What is interesting here to see is that because of CORDEX also, it was agreed that the Cordex domains would focus on two RCPs that were set forth and agreed to under the IPCC guidelines. There is RCP 8.5 here, which is the high emission scenario. And in fact, under the current conditions, despite a lot of efforts being pursued through the Paris Agreement, but unfortunately under the current conditions, these also seem to be more of a business, this seems to be the business as usual scenario as it exists. If you take a more optimistic approach regarding climate change mitigation, and you think that the forcings, that the emissions will actually reduce over time, this is where we stand right now. Business as usual means increased forcings. If we have optimism at this crucial juncture here, where we are in 2020, there is an opportunity to level this so that the emissions, that the radiative forcings are not so high by the end of the century. And this is quite dramatic, and you will see the effect this can have when we look at the outcomes, whether you are looking at an 8.5 RCP output or a 4.5 RCP output. And all our RICCAR work is focused on both of those, that allows for some comparison on what happens from our reference period to the mid-century to the future. So with the thanks of our colleagues at SMHI, a series of regional climate modeling simulations were generated for the Arab domain. Again, as mentioned, they were for RCP. We have generated ensemble projections for RCP 4.5 and 8.5. The historical reference period we used to make the comparative analysis is 1986 to 2005. And then the projections are generated for the period of 2006 to the end of the century. And then you can find and use those data, be it daily, monthly, annual averages, but the simulations are available through the end of the century with reference to this historical period. We have several projections, and these projections were generated into ensembles that we will talk about shortly. Oh, I regret. And all these were generated at a scale of 50 kilometers square, with a couple generated at the 25 kilometers square for testing purposes. So while we have generated that under RICCAR with the thanks of our partners at SMHI, I wanted to highlight that because Cordex has accepted the Arab MENA domain as one of its own, several other modeling centers have used the domain to also conduct projections and generate projections for the region. For example, the Bogazizi University in Turkey has generated a couple projections and have made them even available on the Earth System Grid Federation nodes that are available for climate modeling centers to access data sets and projections coming out of modeling exercises. The Italian group CMCC has generated. Morocco has generated at the Met Service. Our friends at the International Center for Biosaline Agriculture in Dubai have generated, and of course Sweden. However, and right now the MENA domain outputs are also hosted by Cyprus, the Cyprus Institute, which is hosting the MENA domain under Cordex. However, for you as researchers, the only projections now openly available are those available on the ESGS, and you'll hear more about this in the next session, or on the RICCAR Knowledge Hub, where all the outputs from SMHI are openly available. Cyprus does allow them on request, but the others have not provided access. So this is also unique because you can access this information that is open available to conduct your own research. So how do these projections look? I'm not going to delve so much in findings, but how they are presented, so you better understand then what type of data you will need to conduct your analysis and visualize this in an ArcGIS platform. So in terms of outputs, it's important to think of what time scale you're interested in. As I mentioned, all our projections look at RCP 4.5, the moderate, and the business as usual high emission scenario 8.5. We look at the historical reference period. Generally, as a first step, we have the mid-century, which is a 20-year period from 2046 to 2065. and then the last 20 years of the century to provide a comparative assessment of the changes in temperature or to changes in any parameter relative to the historical period. And you can see here that under this moderate case scenario, temperatures, for example, in the northern part in the Maghreb, in the northern part, are on average about 18 degrees Celsius. However, by mid-century, it gets a little bit more yellow. The temperature increases 1 to 2 degrees on average by mid-century, and by end century, we're talking about 2 to 3 degrees increasing in temperature. If we look at the higher emission scenario, the 8.5, you can see that, okay, well, we're at the same historical reference period with this 18 degree or so average temperature. But already by mid-century, you are reaching temperatures of 2 to 3 degrees increase. And by the end, you could even reach 4 to 5 degrees Celsius increased temperatures on average. So it's really dramatic, the difference, whether or not you are forecasting and planning and analyzing outputs at the RCP 4.5 or 8.5, because this will influence how your other analysis goes forward. What's also interesting here to consider is that since the data is available, it's daily data available basically from the reference period for a 100-year period, that information can be segmented into different 20-year increments or different time scales. That's not only important in terms of year averages, but also seasonal averages. And we know as we think about agricultural implications of climate change and crop growth, that changes or shifts in seasons are important to consider. So you can actually generate from the climate data that you'll be presented and learn more how to use using ArcGIS during the series, you'll be able to generate, let's say, averages for winter and summer. So December, January, February, June, July, August, to see what the changes in temperature might be seasonally. Rather than using maps, you can also use these graphical approaches where you can see where each projection is taking you. So for the 3-member ensembles that we used, you can see that for RPC 8.5 for the winter, changes in temperature will be here. But for the moderate case scenario, it will be lower, the change in temperature. But this range here, the area you can see through the parentheses, shows the range of possibilities presented by these projections. Same in summer, for the summer. This is the range of possibilities, and of course the temperature is much steeper. It increases much more towards the end of the century for the summer months here. But this is for the outputs for 8.5, while this is the more moderate. So it really makes a difference for you to consider how you perceive the future, how you think your governments or your research centers or your research itself plans to pursue the future, because when you decide that, you'll be able to incorporate then measures for responding to those impacts, be it at a high emissions or more moderate emissions future. So it's not only temperature, of course, we look at. Precipitation is a very important indicator as well to consider. It's set up the same way visually, but again, the information is available. Daily data is available for you to use in other sources. Again, to recap, information is available for both scenarios, RCP 4.5, RCP 8.5. There's the historical, where you can see about how much water is generated monthly on average for this 20-year period, and they do use millimeters per month. That is the indicator used out of the, that is the unit used out of the regional climate models. But you can see then how much drier, or not drier, how much less precipitation there is at mid-century and what happens by end century, and how much less precipitation there is when you look at the 8.5 scenario, where look, it's completely brown. That means a significant loss of 8 millimeters per month for that area in the Maghreb. Again, there's headwaters of the Tigris and Euphrates that are getting less precipitation. But also realize that there are places that more rainfall is going to be experienced and is being projected. Now, that does not mean more over a course of a year. This could mean this could provide a signal of more extreme rainfall events, which then also has to be considered in terms of flooding, and other indicators need to be used then to understand a bit more what this means. And that's why, rather than just looking at those essential climate variables such as temperature and precipitation, wind speed, we also talk about extreme climate indices, which can better inform your analysis and move forward, especially as we think about the number of hot days, the number of peaks in temperature, the dry spells, the wet spells, precipitation intensity, etc. So the ones that we are working on, and again, this commonly used globally, are the extreme temperature indices and extreme precipitation indices. For temperature, I love sharing this example that when we started our work, the results were being generated for the number of hot days over 25 degrees Celsius, the number of summer days above 35 degrees Celsius. But if anyone has, any of you who have lived in the Arab region, you know that, well, 25 is basically almost every day. 35 degrees Celsius, okay, there's a little bit less per year. But if we're going to really try to find out what a hot day is, we need another indicator. So we actually introduced the indicator number of very hot summer days, which is the number of days above 40 degrees Celsius, which is actually quite frequent in our region. But this helps us better understand those really hot days and the sensitivity of the public and other sectors to that indicator. And that could be taken out from the regional climate modeling outputs. For precipitation, there's a range that you can use. I'm giving you an example of the length of dry spells because it could be correlated to analysis about drought. So you can generate, for example, the maximum length of a dry spell, which means the number of consecutive dry days without rain. And you could see whether that is increasing or decreasing based, again, looking at the reference period, looking at a different time period, the mid-century and end-century, for either RCP 4.5 or 8.5. And visually, this really helps to capture whether areas are getting wet or dry and according to what time series. And again, you can do your own analysis to see different time slices, though we do encourage 20-year time periods so that you get a good average on what those signals are. So we've been giving you a framework regarding the regional climate modeling work and how that is done. So you understand the types of information you need to have in hand to use these modeling outputs to inform work on water, food, agriculture, health, and other sectors using ArcGIS tools. But it does not stop there. We take, as I mentioned, we have an integrated assessment. So our first part of this integrated assessment dealing with impact assessment takes the regional climate modeling outputs that we've generated and links it to hydrological models. This is important because it provides us with a better understanding of climate change impacts for the water sector, which is the crucial component that we have been examining and that was requested by our member states. These outputs, the hydrological modeling outputs, are based on a bias correction of the regional climate modeling outputs. So what we also have done, and thanks to our colleagues at SMHI and our partners, we've taken the raw outputs from regional climate models. They've been bias corrected by checking back on the observations so that they can be used with more confidence for regional hydrological modeling. And then to have greater understanding, those were calibrated and used for VIC and HYPE. HYPE is actually a semi-distributed catchment model used commonly by SMHI. They describe hydrological processes for different basins for the purpose of general conceptual multi-basin analysis. And that's what we did since we were looking at basins across both shared and national water basins, surface water basins across the Arab region. There was also the use of VIC, which is the variable infiltration capacity model, also a semi-distributed macro scale hydro model that looks at water energy balances. That's coming out of the United States from the University of Washington. And then there were also case studies done by our colleagues with our colleagues at ACSED that looked and used HEC-HMS for flood analysis in 3 basins to assess extreme events in parts of the region. So the outputs, the bias corrected outputs from the RCM, the regional climate model, was then used for 2 hydrological models and even a 3rd to do specialized case studies. What's important to note is, though, that because 2 different models were used does not mean we can combine the results of those models. So when we look at the indicators generated from the hydrological modeling outputs, we divide up not only by not only by the projection, but also by the model. So you'll have, again, this moderate case 4.5 scenario for a mean change in annual runoff. And you'll see that this is historical, and this is what happens by mid-century, end century. And then for comparison, you can see with the VIC model also where the signals are, and they are rather consistent as to where the hotspots and the reduction in annual rainfall is relative to increases. So two different models, but they are two different outputs. We cannot combine them, but that helps to increase our confidence in those results. Well, that is for the RCP 4.5. It's also for 8.5, and you can see that changes and the signals are even more strong, be it mid-century or end century compared to the reference period. But again, differentiating the outputs for HYPE versus VIC. And this is for annual runoff. Another important indicator that came out of the hydro modeling work is evapotranspiration. And this is quite important when we're looking at the use of regional climate modeling, not only for water availability, but also as inputs to agricultural models such as aquacrop. In fact, this is also a reason why we went into the hydrological modeling component, because you can actually find evapotranspiration and draw that from the regional climate modeling outputs, unbiased corrected, just the raw outputs that come from an RCP, from a RCM, but they will not have the same level of confidence or finesse as if you use it as you take those evapotranspiration coming out of a regional hydrological model. So that is why we use this, and this data has been used for a series of case studies that we've been doing on agricultural productivity with our partners around the region. And again, these outputs can be shown for the different scenarios, and you can see how much red. So this is changes in ET for the HYPE model and the VIC model for the high end scenario, reference period, reduction in ET, even more by the end of the century for this scenario. And similar signals are found by end century for VIC as well. So when we presented our preliminary findings to the Arab Ministerial Water Council, there was also interest in looking at smaller specific areas to get a sense of the signals that climate is having on shared water basins, and also areas where, let's say, snowfall or other sensitive areas in the region where we needed more fine-tuned analysis. And therefore, we worked with our partners to collectively, we've identified a series of smaller domains. These are extractions from the Arab domain projections, but it provides more finer scale analysis in these parts of the areas, these parts of the region, which are also available for you to use. Rather than maps, hydrographs were generated, or graphical representations of some of the indicators to get a better sense. So for example, in the Moroccan highlands, that was a smaller domain identified. You can see for the HYPE model and for the VIC model, the reduction, be it for RCP 4.5 or RCP 8.5. And this provides another visualization, another set of data that can be used to inform work at a smaller scale. And again, you can do this yourself once you have access and are able to access the information on your own. Transboundary water resources, very fundamental priority for this region. Therefore, the headwaters of the Tigris-Euphrates, headwaters for the Nile, the Jordan River, we also did analysis. Again, we're not dwelling on the findings so much here, but what you can generate and what information can be generated from the projections and the hydrological modeling outputs. So you can see, for example, the different outcomes for temperature for this basin. You can see changes in annual discharge, the changes depending if you are on the 4.5 or 8.5 projection. You can see changes on what it means for runoff. And again, I highlight the importance of deciding what is your optimism about changes in the radiative forcings in the atmosphere, because for RCP 4.5, for example, runoff in the upper Euphrates River is about -2%. But when we're talking the business as usual, it can go down to 12%. So it really makes a difference which scenario you're using. And when you also receive information to better understand which scenario is being used, when you process and examine information generated by others. This is the outcomes for the Tigris, upper Tigris Euphrates. And again, same type of analysis can be done for essential climate variables like seasonal temperature, as well as the extreme climate indicators such as consecutive dry days, wet days, etc., drawing from the RCM outputs. Just another example, for the Jordan River, again, 3-member ensembles for RCP 4.5 and 8.5. We cannot combine what comes out of a height model or VIC, but showing them next to each other, the HYPE, and the VIC for certain indicators helps us better understand and have confidence in the outcomes. What's also interesting is the height model, not VIC, can also generate just discharge, and that might be something that is interesting for some surface water basins that you might wish to explore further. So let's just take a little stretching break now. We're finished with the core part of the presentation, so just stretch a little bit. We're almost there, just about a dozen more slides. And we'll then get back into wrapping this up, and I hope you've been having an active chat also on the sides as we are presenting this. So where were we? We have now the whole component that we've been talking so far is really the parameters and ways we can understand and use information from the impact assessment component of the integrated assessment. But this is really just the beginning. It's really the biophysical components. What does this mean for vulnerability? Because vulnerability is about people, about responsiveness, about how we deal with those impacts. And therefore, we have taken the impact assessment outcomes to inform a regional vulnerability assessment, which I think would be quite important, particularly as you inform, if you're doing work to inform policymakers at any scale of government, and of course, local stakeholders. So what is this integrated vulnerability assessment? We have taken the outputs of the impact assessment, be it the the regional climate modeling or the hydrological modeling outputs, to represent exposure to climate change in the vulnerability assessment. We've associated with the sensitivity of certain parameters to that exposure, but still in a biophysical type of environment, though there are population indicators and access to some services put there. But these combined then generate a potential impact to climate change. But that isn't sufficient, because our ability to respond and address climate change impacts really has to do with our adaptive capacity as well. How are we able to address those challenges, be it both nationally, locally, our capacity economically to move forward? And that combined potential impact and adaptive capacity then leads us to an assessment of vulnerability. And to break that down a little bit more, but again, this will be the subject of a full webinar session, webinar 6 it is, at the end on August 5th. You'll see that how indicators were selected from the exposure, such as changes in temperature, precipitation, extreme events indicators, and for determining the vulnerability of water availability for the region. We selected 6 exposure indicators through a very consultative process involving about 200 experts from the region to identify these indicators, as well as which sensitivity indicators to consider. And these sensitivity indicators thought about various parameters related to population, man-made like surface area and areas served by dams, and natural infrastructure that is affected and how sensitive they are to exposure of the exposure indicators. And that again generates potential impact. But then we added the adaptive capacity, because I think we all know that, let's say, Lebanon, with its resources and its debt crisis going on right now, compared to another country that might be more wealthy endowed, let's say in the Gulf, would have a different level of adaptive capacity to respond to climate change challenges than others. Same with the Arab least developed countries compared to the more wealthy areas. The difference in adaptive capacity makes a difference in our vulnerability to climate change. And for adaptive capacity, as you can see, there's a range of sub-indicators indicators that were identified related to knowledge and awareness, technology, institutions and governance, infrastructure, economic resource, and of course, equity. So each of those indicators were collected and gathered for the Arab states. They were classified, and you'll hear more about that again in the next webinar. They were aggregated to create a vulnerability index by basically using ArcGIS to create analysis of vulnerability for the region. We did this not only for water availability, but for a host of sectors. For the environmental biodiversity ecosystem sectors, we looked at forests and wetlands. For agriculture, it wasn't agriculture at large, but we differentiated between crops and livestock. For human settlements, we looked at inland flooding. And for the people sector, we looked at water available for drinking specifically, heat stress, and the employment rate for agricultural sectors, which is really quite important, especially since women are significantly employed in the agricultural sector, and since agriculture is such an important component of the economies of several countries in the region. So how do these vulnerability assessments look? Well, we have them presented in a similar way to the regional climate modeling outputs in hydro, where we take a reference period. We compare it to mid-century to end century, but again, you're able to identify the time periods you want based on once you have the data and have identified your question to answer. But for water availability, let me give the example here to give you a sample of a reference period. This is water availability based on the set of indicators provided for the period 1986 to 2005. When we look at mid-century, this is the additional vulnerability. You see that some areas are a little bit more vulnerable. For RCP 4.5, again, this moderate scenario. And then it gets even darker. So you're even getting higher vulnerability by the end of the century for parts of the region in terms of their vulnerability to climate change for RCP 4.5. So again, this is the moderate scenario by the end of the century. If you jump to RCP 8.5, and I'm just giving as an example here, look how much more red it is, how much more vulnerable the region is to climate change. So it's not only what we just saw in terms of parts of the region that are sensitive to changes in climate and the vulnerability by end century, but even more so, you can see the hotspots emerging as we look at the higher end, higher emission scenario. So just to drive the point home about the difference between potential impact and adaptive capacity, since some parts of the region will actually be getting more rainfall, there's ways the potential impact has one story in terms of what it means by the end of the century for water availability. This is just, and while there will be sensitivities associated with potential impact, it does not tell the whole story, because this is how adaptive capacity means. So you have to really look for vulnerability both at the impacts and our ability to respond to those impacts to really demonstrate the socioeconomic dimensions that affect the region, your communities, to respond to climate change. So just to wrap up on this, all the data used for RICCAR, all the data generated for RICCAR is available as a quick reference. For the exposure, the NetCDF, the GIS raster and classified data sheets, the actual maps, the fact sheets are available. The Excel sheets are available. The maps for the sensitivity indicators, the data sheets, also for the adaptive capacity indicators, all that is available in various file formats on the Regional Knowledge Hub or upon request if it's not available on the time step that you are most interested in. Several countries have already been using this. As I mentioned, they're using this for agricultural productivity models using aquacrop. The Lebanese Ministry of Agriculture has been working with us and our partners at ACSED and with the support initially of GIZ to produce a vulnerability assessment of the agricultural sector for Lebanon. Again, the details are available in a report produced by the ministry with CNRS, and you can see how this can be done at different scales of analysis and the scale of your choice. All the information that we are discussing is available on our Regional Knowledge Hub. It provides knowledge resources as well as access to the data. It's available at www.riccar.org, very simple to remember. This is the publications that have been produced to date since the modeling outputs came out in 2017. The main report is available fully in Arabic and English for anyone to access. It's able to be downloaded. Detailed technical annexes of all the maps, again with those 3 time steps, historical, mid-century, and century, is also available for download on the technical annex. A series of case study reports have been generated for health, for extreme events like the floods that we were mentioning, for the green sectors, for agriculture, for disasters have been generated and is available online. And then there are explanatory technical notes for the methodology, as well as training manuals available for download. Indeed, the training module on GIS tools for climate change analysis is already available. There is available online. It will be up in Arabic soon as well, and that will be the basis for much of the training being provided over the next 5 weeks by Marlene. All this information has been used to inform adaptation in other sectors. There are adaptation nodes. There's a node on negotiations, on the work of the Arab Climate Outlook Forum. That is available on the website, and you can access that from RICCAR.org. And then our partners at FAO are hosting the data portal that provides data access and the maps generated by RICCAR. You can access it again by RICCAR.org or going straight to this website hosted by FAO, and that's where you can access. And again, if the information there is not available, there is a data request form on the RICCAR site, and we can provide that to you. All this work at RICCAR is being pursued at ESCWA within the framework of our Arab Center for Climate Change Policies. It works on a range of issues, but it was established in June 2018, and we continue to support our Arab states on climate change, be it on assessment or on the range of climate change issues that affect the region. So with that, I encourage you to take this opening presentation to help you to think what type of information you need, what type of analysis you would like to pursue, at what scale. When doing so, think about if you need outputs or inputs for use of other models. Think about the scale of analysis you're most interested in pursuing. Do you need outputs at a very large global scale or something that is finer scale, 25, 50 kilometer squares, or even 10, especially in areas with different topography? Are you looking for essential climate variables like temperature and precipitation, or do you need also to look at extreme climate indices to strengthen your analysis? Which domain is best for you? Again, we've been talking about the Arab MENA domain. We'll have an upcoming Mashriq domain, but there is a Mediterranean domain, there's a European domain, there's an African domain, and you can combine analysis drawn from those ensemble outputs generated for those various domains to better inform your work. Very important for you also to consider the scenario that is most relevant for your work, and to generate ensembles, at least 3 projections. One projection is not enough. You have to have at least 3 to understand the range of uncertainty associated with an ensemble output. And of course, what is the time period that you aim to cover in your analysis? We encourage at least a 10-year time step. 20-year time steps are better, but think in terms of what is your reference period and what you want to compare with when you move forward with your climate analysis. And we are there to help you as you draw on this data to conduct your work. So thank you very much. Joël, how are we doing? I know we have about 5 minutes left. Are there any questions that you and Marlene have not already responded to?
Hi, yeah, Carol, we have a list of questions. We are responding to them as much as we can. We have a question on how can we decide whether RCP 4.5 or RCP 8.5 should be chosen to take management measures. So if you can answer that.
Yes, thank you very much, Joël. That's actually a very important question, and it really links into your vision as a researcher and as a state as to how you want to go forward. So deciding whether you want to use RCP 4.5 means that you have a very positive outlook, that states will take on account mitigation measures in order to reduce, and not only your state, but the states of the world, countries of the world, the private actors of the world, civil society globally, will take the necessary actions to reduce emissions in the near term. We've already said that we are at a tipping point, and the Paris Agreement had already tried to aim for no more than 2 degrees Celsius by the end of the century as an increase. But that is a very optimistic target right now to reach. So if you are optimistic that engagements in renewable energy and changes in consumption pattern and efficiency gains will help us to reduce efficiency, you have an optimistic outlook, use RCP 4.5. But if you think, especially if you are perhaps more concerned about energy transitions away from oil and gas, coal, for any of the ones who are engaged in coal production, if you think that those producers of those energy will not be able to generate the efficiency gains or changes in production pattern will not be achieved, and you think that the business as usual, that we are moving forward, but maybe not as aggressively as we need to achieve that global goal, I would encourage you to use the RCP 8.5, because that is more the business as usual approach. That is not as aggressive, making adjustments, but maybe not as aggressive. So that's a way that you can decide. And it really is your perception and your understanding of where the negotiations are, both in your countries, across the region, and across the globe. Is there a last one that we can add in there? Or Joelle?
It's fine. I think we have, Marlene and I were replying to all the questions we're receiving.
Wonderful.
If you want to just mention maybe how can they reach out to us for additional questions or follow-up questions.
Very good. Very good. Well, again, this is to provide an introduction about some of the basics. Marlene will be with you for the next 5 weeks on Wednesday to provide step-by-step ways on how you can better access the data and use it for different types of analysis. My email address is right there on the screen, shushanisherfain@un.org. Please feel free to contact me. If you are looking to actually use this for climate modeling exercises, I encourage you maybe to wait a few sessions. Contact Marlene once you have a better understanding on how you can use these tools. Her website, her email address is already on the flyer that you have on the web page that we communicated to you before. Again, I'll go back to that web page so you can revisit that. Sorry. And please go to this site where you can find all the information and the generated from this webinar series. Her email is available on the flyer. And again, the recordings and the handouts generated and used in each of these sessions will also be available on this site. Okay. So I think we can wrap this up. I know I can see on the side a very active discussion on the sidelines. I hope all of you have put in your names so we can see that you are logged in and we're able to exchange a little bit with colleagues. Thank you very much for your active engagement in this event, and we hope that you will join us next week on Wednesday at 3 p.m. Beirut time as we move forward to the next phase of this webinar series. So thank you very much. Have a good day.